afternoon, everyone. My name is Aisha Hyder. I'm the Tech Transfer Program Manager here at the Doolittle Institute, and it's our pleasure to welcome you all to the Technical Showcase event series. Before we get started, I'd like to do a quick comm check with Dr. Petrock. Dr. Petrock, are you on the call?
Yes, I'm here. Can you hear me okay?
Yes, we can. Thank you very much. I'm going to do a quick intro from our end. For all of you folks that have dialed in today, again, thank you for joining us. The Doolittle Institute is an Air Force Research Lab Innovation Institute and DefenseWorks Innovation Hub. We are partnered with the Air Force Research Lab Munitions Directorate to support their work to license and commercialize their technologies in the private sector through technology transfer by identifying and fostering new relationships through innovation and collaboration, and also by developing today's students into tomorrow's workforce through our STEM initiatives. The goal of the Technical Showcase event series is to strengthen and broaden science and technology collaborations among industry, academia, and the Department of Defense through a monthly topic-focused interchange, thus providing opportunities for the government to share its research and technological needs with industry and academia, and for industry and academia to showcase their cutting-edge technologies and capabilities with government stakeholders. Today, I'm pleased to introduce our first guest government collaborator for this month's topic, Multi-Domain Weapons Technologies, Part 1, Terminal Effects, Dr. Anne Marie Petrock of the U.S. Army Combat Capabilities Development Command's Armaments Center, better known as U.S. Army DEVCOM. Dr. Petrock is the Senior Research Scientist for Warheads Technology and serves as a scientific and technical advisor on lethal mechanism technologies. She is also the principal proponent for the technical content of the Army's Warhead Science and Technology portfolio, and she also serves as the lead for the Ordnance Key Technology area of the Office of the Undersecretary of Defense for Research and Engineering's Kinetic Weapons Community of Interest. Dr. Petrock, thank you so much for being here with us today. We will be sharing your presentation on your behalf, but please feel free to go ahead and get started and let us know when you would like us to transition to the next slide.
Okay, that's great. Thank you so much for that introduction and the overview. I am really excited to be here today to talk to you about multi-domain technologies. There are so many things happening in the field that we decided it would make more sense to break it up into a two-part series. So today we'll be focusing on the terminal effects, and in June, we will be focusing on tailorable trajectories, which is more on the kind of propulsion and fire control side of things. So we've got some great collaborators and contributors that are going to be briefing us later, and I am really excited to be a part of this. So thank you for allowing one of the Army outsiders to come on in and join the fun. I'm really excited about this. So if you want to go to the next chart, please. I figured that we would get ourselves all on the same page. Everybody kind of is familiar with the term multi-domain operations. I thought that we would start with the U.S. Army training doctrine kind of overview of what it is. So you can see these laminar, nice, cleanly defined areas for multi-domain operations. It includes space, cyberspace, air, land, and sea or maritime. And you can see that they're all individual nodes that are operating and communicating. And it is for military operations across some or all of these domains. And what's enabling them is the integration systems and also strategies and concepts of operations. So if you want to go to the next chart, you'll see that this is more closely aligned with what reality is, right? So we've got these nice clean lines of demarcation on the first chart for training, and then the application of it is not quite so simple. So we start looking at it, and you can see kind of all of the complex interactions between space and sea and air and land, and then you start looking at how cyberspace is integrated between all of them, as well as you'll see some unmanned platform nodes in there, and you'll also see some special operational units in there. So there are a lot of different complexities that are happening, and what this doesn't even include is some of our international partners. So the question is, how do we work effectively in that kind of environment? And the National Defense Strategy offers some comfort and tells us, hey, this is the way we're going to get there. We're going to build upon these three core tenets. and we're going to try and go after this complex problem in these ways. So we're looking at something called integrated deterrence. So basically, if you want to look for peace, you start preparing for war. So you deter your adversaries by making sure that you have synchronized efforts across all the domains, which requires the DoD components and all our partners in industry and academia to put our heads together to figure out the best ways to solve these problems. And so that we can then start working across different regions of the world, as well as the entire spectrum of the conflict, to partner with the instruments of U.S. national power, which are more on the diplomacy side as well as on the defense side. And then we also are going to be looking at different campaign strategies and how we're going to get there. And so this is a synchronization across all of military activities to ensure that the United States is in a position of power. And so those are the two key areas that we're going to focus on in my discussion. And then I'm looking forward to our partners who are going to be briefing, who are going to talk about how we're going to continue building enduring advantages. And that is essentially looking at how we're modernizing the DoD and our infrastructure to be able to be ready and positioned for the future fight. So I'm again excited to see how we're going to work this, how we're going to be engaging on this. So next slide, please. So today we're going to be focusing on the enabling technologies for the integrated deterrence as well as for the campaign. And so there are several key areas within that that are going to enable us these kind of long duration operations. And so it may involve things like loitering munitions and longer engagements where we're more surveilling the landscape rather than necessarily engaging. And so we're going to need the ability to do some real-time analysis and discrimination of what's a target and what's not. We need to be able to identify it and prioritize it. We'll need to be able to track it and then provide prioritization in terms of aim point selection and assignment of the different nodes, whether they're in what domain that they happen to be in. And then finally, looking at prosecution of the target. And so the four key areas that we focused on today are the topic areas of contextual fusing, which is essentially fusing which integrates sensor input with all of the topics that I just described above, the discrimination and identification, the tracking, and the prioritization, but it's doing it in the context of the battle space it's located in. And so it's a real-time type of capability, which is able to integrate all of that sensor information and provide that feedback that says, hey, I have nodes in these locations, this is the best way to go after the target. In order to do that, we're going to need to have some advanced data collection and processing capabilities that are on board with each of these types of individual systems. And so it's going to require a lot more power to power not only the microprocessors that are doing all of the analytics, but also the sensors that are searching the landscape. Additionally, we're going to need to be able to have some smarter lethal technologies, and so that would come in the way of novel initiation, enhanced explosives, and also some selectable warhead technologies. We'll get into that in a little bit here in the next couple of charts. Next chart, please. Okay, so for contextual fusing, advanced data analytics, and next-gen power, we're looking at two kind of key thrust areas. So one is going to be that on-the-fly discrimination and targeting, which I just described, but this is going to be using a fusion of sensor and also effector information. And so it's going to require a two-way communication between the individual nodes and each other, as well as whatever the command node happens to be, whether that's kind of a person or a command, a group, and being able to effectively communicate across some contested areas. So we talked to robustness here, and so we know that there are some computer vision and AI challenges, which although AI seems to be this real sexy topic right now, there are still a lot of challenges to being able to field it. And so, spoofing is a real challenge. When you've got a technology that can be fooled into thinking an Apple is an iPhone with something as simple as a Post-it note, we have some work ahead of us to make sure that this is ready for the battle space. And so when I talk about robustness for the discrimination and targeting, specifically I'm referring to things like the computer vision challenges. How do we overcome the limitations of weather in the area that we're engaging, and geography? Also miscalculations. I mean, we talk about tolerance stacking from a building perspective. So when we're building a munition, tolerance stacking can become a real bear, and suddenly things don't fit as well. But when we have miscalculations between, tens of nodes or even hundreds of nodes, small miscalculations can, in location and time, can really add up to a failed effort, or a failed campaign. So we need to be able to address that kind of stuff and know that we have information surety when we're doing these. And then, of course, contested areas. We've got areas where RF, GPS, and all kinds of other sensing modalities can be interfered with, spoofed, or interrupted. So we're going to have to start looking at that. Or I guess we are looking at that, but that's what we're going to be talking about today. Now, of course, as you're doing all of this stuff, all of these things, the sensors, the fuse, all of it, it's all power hungry. And so if we've got all these ways that we're sensing the environment, and we're doing all of the processing to figure out how we're going to tell whether something's a target, and whether or not we should actually go after it, we're going to need the processing power to provide that information. And then we're also going to need the power for the communication systems to be able to project that through whatever type of environment it's located. So we need to make sure that between nodes, as well as between the nodes and the commanders, that can take place. And then, of course, a latency issue is always a challenge. We really need to focus on getting real-time sensing that can be packaged small enough to go into a system that we're trying to send out. So we've got a constrained volume. We need enhanced capabilities. So the real-time sensing will get us a long way, as long as we can do it without increasing the power consumption needs or the space or the thermal issues. And so the analysis, decision-making, and comms to other nodes and to command, they all need to be happening in real time. And so again, when we talk about kind of tolerance stacking, I know that's not really how folks describe it in these fields, but when we talk about that, we have small errors that can add up to significant issues and challenges with completing the mission. So all of those are critical features for the contextual fusing and data analytics. Furthermore, if we're going to use that to support deeper fires and extended ranges and durations, we now have to think about survivability from a different perspective, which is, can these things that we're designing survive gun launch or whatever the launch environment is? Can they survive the trajectory conditions? Could be extended vibration, it could be thermal cycling, it could be all kinds of interesting things. Can we build these so that they are survivable and robust, and then also be survivable when they start getting into the area of countermeasures? And then we consider power in this specific application for the actual implementation of the power. So typically, if we have a thermal battery, for example, we will ignite that, and it will burn, and it will give us a specific duration, and it will burn at the same rate, independent of what the power consumption needs actually are. So we have energy that's lost that could be used more efficiently. And it's typically initiated at launch, but perhaps we don't need the sensors until we're somewhere mid-flight. So some different intelligence that can get associated with the power usage. And we all know that size has a tendency of scaling with duration of the power and the power levels. And so the bigger that gets, the smaller the lethal effect at the other end can be. And so it's limiting our other capabilities. And that capability could be in just the sensing in general, and we can't put as many sensor packages into the round, or we have to have a smaller warhead, whatever the case may be. And finally, we're going to need to have the energy left over to be able to have some maneuver authority to close with the target. And whether that's the power of it, the power aspect to make sure that we can have that capability to maneuver, whether it's the fusing that says, hey, this is actually what I want to engage in with certainty, this is what we're going to do, and then also have the power to initiate the effect. So it still needs to have some kind of extra power to engage. So those are all, those are some of the considerations that go into how we're going to go after this problem. Okay, next chart, please. So when we talk about novel initiation, explosives, and tailorable effects, we start talking about ways that we're going to get around the fact that we're going to have all these new sensors and all these new communications modules, and the larger power module that's going to be required to be able to do all of these mission functions. Because at the end of the day, we're still going to need to have the effect on target, but we're going to need to have smarter warhead capabilities to get there. And so this specific piece of it is looking at ignition for terminal maneuvering and also for terminal engagement. This is, the ignition is no longer just sensors, the system is no longer just dependent on the sensors at the terminal engagement. So for example, we're not just looking at, hey, I have a proximity fuse that's telling me when I'm near my target. We are actually talking about using onboard analytics to determine the best combination of temporal and spatial aspects to achieve the effects on target that we're aiming for. So we can have items set up the way we need to within the battle space, and we can start initiating them properly and enhancing the effects we have given the smaller volume that we'll have to work with. So kind of to close this out, the smaller, more lethal payloads are going to be enabled by these higher performance explosives, the smarter initiation aspects, as well as kind of the tailorable effects that can be generated in smarter warheads. And I think those were kind of the key detailed areas that I wanted to get into. Essentially, just to kind of wrap this up, for the multi-domain operations, we are looking at component technology development, and we cannot forget how critical system integration is to transforming that military landscape. So all these buzzwords of AI and ML and additive manufacturing and field forward things, I guess I would caution that and say that while they hold promise, I don't know that they're necessarily the cure-all. And so if we are going to head down those paths, we should be paying attention to all of the simple countermeasures that occur across the board with all of these new technologies that we want to introduce, and be thinking about that in terms of countermeasures, denial, deception, and camouflage, and how all of that new technology is critical, but also very sensitive to those types of attacks. And so we need to be considering those during our design and integration phases. And then we have to make sure that the system itself is robust to the loss of nodes, whether they are small unmanned platforms, whether it's the communications links, whether it's the cyber aspects of the entire network. So we need to make sure that these nodes can operate standalone as well as with each other and across domains, as well as being modular, so that if we change our mind and we say we just want to do some kind of a single domain engagement, we can take that technology and use it there as well. So we're not restraining ourselves, and that will help get us to the point where we have a more robust trade space within that within the future concepts. I think with that, I am going to end, and I will open the floor to any questions.
Dr. Petrock, we do have a question. It says some of the focus of advanced sensors and more capable warheads are common with the U.S. Air Force. In the past, because of Army scale and quantities, cost of advanced concepts has been a showstopper. How will cost be handled for the advances?
That is a persistent challenge across all Army commodities. Typically, there's a little more of an appetite for the precision and communication aspects and sensor packages within the missile command. And so that I don't anticipate is going to change. the Army is aware that they're going to have some different perspectives. However, they are still pushing for reduction of cost in any way that they can. So those items that are the large kind of volume buys that we're talking about, more of the artillery stuff, I think the fire control is where we would invest more in making sure that we have those capabilities. And so having a smarter fuse that can do it kind of at the outset, based on sensor nodes that are out in the theater, that are out on the field. So I don't envision the Army saying, yes, we're going to have these high-end sensors in every artillery round. It's just not cost effective. However, I do think that they are looking, well, I know that they're looking at incorporating that intelligence in other ways so that it's not used up in every single iteration of everything that's fired. So they're looking at cost-saving metrics and kind of from a different perspective.
Any other questions for Dr. Petrock? If you do have any more, please feel free to type them into the chat. If you would like to engage with Dr. Petrock, you can contact the Doolittle Institute at technicalshowcase@doolittleinstitute.org. Also, if you are interested in collaborating with the Air Force Research Lab Munitions Directorate through the Air Delivered Effects Broad Agency Announcement to develop munitions and other related technologies, you can contact us to schedule a meeting. We can go into detail on what these technologies are and what the process is for engaging with AFRL RW. We are looking for partnerships with industry and academia in areas such as autonomous target recognition, sensors, navigation, and cyber resiliency. And we also have some licensing opportunities for technology that was developed in the lab that industry and academia can access through licensing agreements. I don't see any more questions. Our next technical showcase will take place on June 8th and will again feature Dr. Petrock. The second portion of the multi-domain weapons technologies topic will be focused on tailorable effects, and the submission window will open tomorrow. So if you're interested in participating, be on the lookout for that and definitely get your submissions in as soon as possible. To stay up to date on upcoming technical showcases, please register for our newsletter at doolitttleinstitute.org and follow the Doolittle Institute on social media. There will be many future opportunities for industry and academia to submit applications to highlight their cutting-edge technological capabilities and also to learn more about what the Munitions Directorate and other featured DoD collaborators are working on. Additionally, Dr. Petrock's presentation from today will be posted on our website. If you'd like to review it in the future, you can do so. In the absence of any more questions for Dr. Petrock, I'd like to thank everybody that attended today. Thank you also, Dr. Petrock. We look forward to joining you again in June. And have a great afternoon, everyone. Thank you.